We could have one variable and two variable. That is true. And then we also have quantitative and qualitative. Qualitative is not the word that AP Statistics uses, strangely enough, but it is correct. And then categorical and quantitative are the two types of variables that we need. And I think it's really important in the very, very beginning to look at a set of data and determine which category, well, I won't say which category, which type of variable that falls into. Is it a categorical variable where someone falls into a category, or is it a quantitative variable? Once you do that, if you do it from the beginning, then that gives you the opportunity when you get to inference later in the year. It makes part of that process a whole lot easier, which we'll get to in just a few weeks. So yes, we have categorical and we have quantitative. And I see people also putting in the chat things like discrete and continuous. That is also true. We do have continuous data, things that fall like on a normal curve, and then we have discrete data where you fall into a bin. So that's almost kind of like categorical and quantitative. But there are some quantitative variables that also are discrete. Shoe size, for instance, like you couldn't get a shoe size of 12 and 7/8 unless you have some custom made shoes for some strange reason. But that is a quantitative. You could take the average shoe size. So categorical data is a type of variable in which each individual falls into a category or a set rather than being assigned a particular number. For example, if we were looking to poll everyone's favorite color, this would be categorical data. I couldn't take the average favorite color. Okay, that's just not a thing. Okay, so you like red, you like blue, you like green. Maybe you're more exotic and you like something like coral. Okay, but either way, you fall into a color category. I can't say the average is red and a half. Okay, that doesn't make sense. And then quantitative data is a type of variable in which an individual is assigned a quantity or a number. I always like to say, is this data averageable? Can I take the average of everybody's number? And if so, then it is quantitative. For instance, if we were to gather everyone's height in inches, this would be a quantitative variable. Because it's totally plausible to take the average height of everyone. That totally makes sense. Okay. This distinction, again, this is what I was talking about. It's important in the very beginning to bring up this idea because it's going to ultimately decide what type of inference procedure you do, what type of graph might be appropriate to represent your data. So another way of thinking about it is proportions, which is categorical data. If you're already in inference in your normal class, you would have, like a one prop Z test or a one prop Z interval. Okay, it's proportions because it's categorical. Means also would be quantitative. So if you're doing like a T test or a T interval. Okay, I see some good questions in the chat. So if you turn colors into numbers, then would it be quantitative? I don't really think so, because I don't think it would make sense if I said the average favorite color was 2.5, which would be somewhere between red and yellow. That doesn't really tell you much. I guess technically, mathematically, you could do that, but I don't think that would really do much for the it wouldn't really do much for the statistical analysis. It would be much better to do a pie chart or a frequency chart and that sort of thing. And then, you couldn't really take the average, that sort of thing. A box plot wouldn't make sense because that difference between like a red and a yellow, there's my southern accent, I just said yeller. Between a red and yellow, it's not like a gradual change from red to yellow. It's more, and Sander pretty much summed that up. The numbers don't mean anything with zip code. So 35034 and 35035, like they might be close to each other, but there's no transition between the two, if that makes sense. Just like red being 2 and yeller being 3, I'm just going to go with it. That you have that, there's no gradual change. It's not a gradient change from red to yellow. It just is. Those are good questions. Those are really good questions. That almost makes you think you could turn anything into quantitative, and not quite. I think the good question to ask yourself is, does it make sense to average the data there? So let's go through some examples here, and we're going to open up the poll to see whether the following measurements are categorical or quantitative. So the first one is age in years. So categorical or quantitative. Starting to get some results here. And it looks like we are all in agreement at quantitative. We got a few people maybe saying categorical. All right, let's see what we got. So our results, mostly quantitative. A few people said categorical. And I can sort of see that where you'd say you're either 2 or 3, you fall into a bin of 2 and 3. But again, I think the question comes down to, is it averageable? Can I average the age of someone and say the average age is 27.5? And that totally makes sense. You can have an average age that is between 2 years. That amount of being between 27 and 28 years actually has some meaning to it. So I think that it's totally plausible there to, okay. So I think that's a totally plausible. All right, I got to retype that, so I'm going to abbreviate, speed things up here. So the next one, all right. Month of your birthday. Okay. So categorical or quantitative? What do you guys think on this one? Cat or quan? All right, a few more seconds on this. All right, looks like everybody is on the same page here. And this was great because this one is a little bit tricky. 100% said categorical. I would 100% agree. Because when you're talking about the month of someone's birthday, it's tempting to say, well, I was born in May, so I could say it's 5. However, that 5 again is just a number assigned to a category. That number means nothing if you're looking at maybe the Chinese New Year, which they start their new year in February. So I'm not sure how they number their months if they follow the same calendar we do, but the first month of their year might appear a little bit different. Okay, so that number really is only assigned to the month in the order that we do them. That could be different in other cultures. So it does not necessarily, number really doesn't mean anything, kind of like the last example we had. Okay, so right or left-handed? Okay. I am going even shorter this time on the poll. Create, show, hide, open poll. There we go. So, man, these polls keep changing locations on me. C or Q? There we go. All right, getting a lot of votes here for categorical, which is definitely correct. We're not going to hang out there anymore. That one's a little bit more easier. So definitely, you're right or left-handed. Now, you could be ambidextrous and be able to write with both hands, and I'm super jealous of you if that's the case. I've tried to play drums before, and if you play drums, I don't know if anybody does that. You have to be able to use your right and left hand and your right and left foot. Not me. Okay, I can play guitar, so I can separate my right and my left hand a little bit, but you add feet in there, not for me at all. So if you play drums, I totally am jealous of that. Well, last one, and then we'll move on. So favorite sport. Categorical, quantitative. All right, again, categorical appears to be the favorite, and I would agree. Categorical is definitely the choice here. Okay. Y'all know my favorite sport, hockey. I've already told you that, which is very odd. I'm from Alabama. Not very many people are hockey fans in Alabama, so I get a lot of strange looks. It's all football. But it is what it is. So anyway, so yeah, that is really important, guys, because when you're doing that, when you get into later things in the year, it's important to be able to determine, is it quantitative or categorical? Am I going to proceed with means or proportions with the way that I do my z-test or t-test? Okay. So then the other one is taco or burrito. I really just wanted to use the emojis there. That is also categorical. So if we're looking at categorical data, we have different ways in which that can be represented. We could have a bar chart. That's a common way of doing it. We could have something like a frequency table. How many people said taco? How many people said burrito? How many people said Mexican pizza? May you rest in peace. You may have, another way you could represent that is a two-way table, which is when you have a two variable data. So we're not going to spend much time on that today, or even next week, really, because that shows up a lot in the probability chapter, unit 4. So that'll be in a few weeks. Also, you have a mosaic plot, which is something they added into the AP curriculum last year. It didn't show up on the exam, at least none of the options that I saw, since everyone had different exams. But I would expect it to show up this year, being that it is a full exam. So here is an example of a bar chart. Okay, so you can see that everyone falls into a category. Every video game sale. You either are action, action-adventure, adventure, fighting, miscellaneous, platform, puzzle, racing, role-playing, shooter, simulation, sports, and strategy. So lots of Call of Duty games sold, lots of Assassin's Creed, maybe, action. And I would say that's almost role-playing, maybe. I'm not much of a gamer, but just using the ones I know that are popular. I'm surprised sports is not higher, but either way, you can see this as categorical data because you are falling into a certain category. You can't be both. You can't be between two categories other than action-adventure, I guess. And then a mosaic plot. You might not have seen one of these, so I wanted to definitely show you that. So it gives you the counts of the amount of people who own. So you can see the general percentage of SUV, sedan, sports, and truck and wagon across everybody, and then you can see it based off of countries as well. So 25 people in Asia owned an SUV, 10 people in Europe owned an SUV, and 25 in the US owned an SUV. Okay, 90 in the US owned sedan, 78 owned a sedan in Europe, 94 in Asia owned a sedan. So you can see most people over the course of the whole world own sedan, and then you can also see by country how that is. So in the US, the percentage of people who owned a SUV is significantly higher than Europe, whereas a station wagon or a sports car is much higher in Europe. So you can see it's basically a two-way table graphically, but you kind of read it the same way, especially if it gives you the counts. If it doesn't give you the counts, you're looking at how much area it's going to take up. Okay. So those are two ways that you could represent a categorical data there. Yes, mosaic plots could very well be on the test. They added that into the course exam description before last year's administration, but being that last year was so crazy, it didn't show up. I would expect to see a multiple choice question on that. They felt it was important enough to add to the CED. I'm assuming with a full test, you would see a question on that. I would treat it almost the same way as a two-way table, which we'll go to in Unit 4. So we'll go more in depth on that. So then you have quantitative data, okay? And we're going to look at these mostly today because this shows up more often in the Unit 1 type questions you would see on the exam. So you could have a box plot. We'll definitely look at one of those. You could have a density curve, which is like a normal curve. You could see a dot plot, which is just a general representation of all the data points. You could see a histogram, which I see some of you discussing that in the chat over there. You could see a stem and leaf plot. If you have to create one of those, make sure you include the key. That will bump you from a 4 to a 3 on a free response question, just for not putting the 2 line 4 equals 24. Okay. One of those random little things I wanted to mention in case that does show up on a free response. So here's an example of a box plot. This is actually a side-by-side box plot. So the values on, so you're looking at male and female age for Oscar-winning actors. So you have the minimum female. Here you have Q1 female, the median, the Q3, and then this is the highest data point that's not an outlier, and we will discuss outliers in just a second. And then you have 3 outliers, and then you have the same thing for male. So you can see that like the males are typically older when they win an Oscar than females. However, the oldest person to win an Oscar in that time period was female. That looks like around 80 years old. Okay, so definitely be familiar with that, and we will look at those in just a second. So here's a stem and leaf plot. Again, you can see that key. That's super important if it gives you a set of data and asks you to draw out a stem and leaf plot. So 0 line 8 means 8 whatever. Takis eaten at lunch. Okay. 1 line 2 would be 12, 17, 18, and 19, 22, 23, 31, 35, and 40. So somebody ate 40 Takis at lunch. Okay, I'm sure that was very hot. But once you start eating them, you just can't stop. Anyways. So with quantitative variables, you're going to have different statistics that you would want to break out. With a categorical variable, you're more so going to be just looking at percentages. What was the percentage or the raw count? That's really the only statistics you have. The percentage or the raw count of action adventure games bought, etc. So with quantitative variables, you have your mean, okay, your average. That's kind of simple. You add up and divide by how many there was. You also have the standard deviation, which there's a nice messy formula for that. And that is the best way of doing that is to use a calculator. Generally in class, I'll go through the process once. It takes like 15 minutes. And then I say, oh, looky here. If you type your data in L1 and then you go to stat one variable statistics, it does the standard deviation for you. That is way easier and saves you a lot of time. And we'll be doing some calculator stuff on here as the crams go on. Generally, those two go together as well. More on that in a second. The median, which is the number in the middle, it is also known as the 50th percentile, meaning that 50% of the data is at or less than that. The Q1 is the 25th percentile, so that means that the data is 25%. 25% of the data is at that data point or less. That's another change in the AP curriculum that is just a minor change. I really wish they wouldn't have done that, but they did. So percentiles now are at the point or less. It used to just be less. Okay, so that if 6 was the 25th percentile, then we're looking at 25% of the data is less than 6. Now it's less than or equal to 6. Little small change there. If you're doing it in your calculator to create that box plot, one variable stats, that's not going to be something that's going to totally kill your score. But that is the way that they break that out now. Same thing, Q3 is the 75th percentile. The interquartile range, the IQR, is you subtract those two quartiles, Q3 and Q1. Basically, you're finding what is the range of the middle set of data, the middle 50%. So the next thing, and Sandra and I both agreed this was important. If you want to calculate if something is an outlier, if you go back to that box plot we were just looking at, you're going to find the, I should have said interval here, not range. You're going to find the interval between, you're going to take the Q1 and subtract 1.5 times the IQR. That's going to be your lower limit, okay? If you're maybe a calculus person, think of limits. So that is your lower limit. Anything below that is an outlier. And then you're going to take the upper limit, which is Q3 plus 1.5 IQR, which is going to be your upper limit. Anything more than that is going to be an outlier, and is going to be represented on the box plot by either an extra dot or a little star, but it's not going to fall on the whiskers. Okay, so if we go back to the one that we just had, okay, these are outliers. They're not on the whisker. Okay, so my IQR here appears to be 41 minus 22-ish. 41 minus 22. So the IQR looks like it's about 19 for females. Multiply that by 1.5, that's 28.5. So then I'm going to add that to 48, which is 76.5. So I'm a little bit confused on this box plot here. Oh, maybe I looked at something backwards. This is 30, not 20. Maybe that was it. So 32. Let's see, 42 minus 22. So the IQR is 20 times 1.5. So I still got 70. Yeah, it is 32-ish. I looked at the scale wrong. 40 minus 32. There we go. That's what it was. I did my IQR wrong. You're right, Rhea. Hope I said your name right. So the IQR looks like it's about 8 or 10 times 1.5 is 12 plus 40 is 52. So anything more than 52, which is right in here, is going to be an outlier. So 60 is an outlier. Yes, the IQR should be about 9. Sorry, I misread my scale there. So just to recap there, because I totally confused that, totally botched it. The Q3, okay, is this line right here. That is about 40, 41. The Q1 is 32. So then 41 minus 32, the IQR is about 9. 9 times 1.5 is 13.5. And then we're going to add that value to our Q3, which was said was about 41. And that gives us an upper limit of 54.5. So anything more than 54.5 is an outlier. Hence 60, 72, and 80. Okay. And then this value here is the data point. So let's say the next person in line was, it looks like they were about 49. Okay, so this doesn't represent the upper fence. It doesn't represent that upper limit. It represents the last data point that fell within that limit. Okay. All right, let's skip on back ahead. All right, so anyways, that's really important. That's very likely to show up on the AP exam.